Questions over any of the homework assignments? All right. What we're starting with today is these here. Now we're skipping over 2-2, mainly because 2-2 is proofs, and I'm not going to focus too much on those. And what we're starting with is solving these trigonometric equations. Now, when we solve trigonometric equations, there are different ways that we can solve them, and a lot of them revolve around either getting the trig functions by themselves or rewriting as more than one expression being multiplied together. Now, we have one like this here, where it's all in terms of sine, cosine, tangent, secant, cotangent, one term, one trig function without a power. We want to get the trig functions all together and everything else on the other side. So the first thing we can do here is add sine of x to both sides. Because on the right-hand side, negative sine of x plus sine of x is 0. On the left-hand side, sine of x plus sine of x, since they are like terms, we'll have 2 sine of x plus the square root of 2. Now our next step is to get sine of x by itself. So the first thing we can do is subtract the square root of 2 from both sides. Because our square root of 2 minus the square root of 2 is 0. Minus that 2 sine of x is equal to negative square root of 2. Get sine of x by itself. No, so the last thing we need to do is divide both sides by 2, telling us that sine of x is equal to negative square root of 2 over 2. Questions on this here? We good at getting to at least this spot here. Now the next step, we can use the calculator. Using the unit circle is going to be helpful, especially with these here, because sine of x and cosine of x on the interval of 0 to 2 pi on that unit circle, all except for one value, will have 2 values of x that will work for this here. Because sine of x equals negative square root of 2 over 2. It is true, because again, when we look at the unit circle, we're looking for the y value of the points at when x is equal to 5 pi over 4, and when x is equal to 7 pi over 4. Now the graph or either calculator will tell you if we did sine inverse of negative square root of 2 over 2, it will tell us that x is equal to negative pi over 4. We want it in a positive angle case, because we do have these two here. I pull up the 30xs, we'll have to change it over to radians, because if we looked at sine of 5 pi over 4, we get negative square root 2 over 2. Now sine of 7 pi over 4 is also negative square root 2 over 2. Questions on this here? Now what's also interesting is, again, these are solutions, and it told us to find and solve for what values of x would make this true. Well, because of the fact that sine, cosine, tangent, secant, cotangent are cyclic functions, they repeat themselves, sine of x does indeed equal negative square root 2 over 2 at 5 pi over 4 and 7 pi over 4. But it's also true for all of its coterminal angles, any that repeat themselves, any other of those there. Well, 5 pi over 4, if we add 2 pi to it, we get 13 pi over 4. So sine of 13 pi over 4 will give us negative square root 2 over 2. And if we add another 2 pi to it, we'll still get negative square root 2 over 2 because every single coterminal angle for those there will still work. Does that make sense? Questions? So, coterminal angles. You remember from chapter 1 where we said 5 pi over 4, if we add 2 pi, we get to the same angle. So that means every coterminal angle with 5 pi over 4 is a solution. So if I add 2 pi to it, 13 pi over 4. If I take sine of 13 pi over 4, we get negative square root 2 over 2. It is a solution. If we add another 21 pi over 4, it's a solution. Because every coterminal angle, and we have to list all of them, our solutions are 2 pi in. We're saying that any coterminal angle for this here is a solution. And the reason we have to add this is because it did not specify what x is, what our angle is. Now, if it said that our angle is between 0 and 2 pi, or 0 and 360, we don't have to add 2 pi in for sine and cosine, or pi in, the period, for tangent or cotangent. But because it did not specify our angle, we have to add this in. We have to include every single coterminal angle, positive or negative. And n just represents which iteration, which coterminal angle, going in either direction. Questions? Yes, they are different because 5 pi over 4, if we look at the unit circle, would be an angle down here at 5 pi over 4. 7 pi over 4 would be down here. So they're in second, third, and fourth quadrant. That's why they're different. Is that? Yeah. Because again, the unit circle gives us the sine and cosine value. And we're looking for where sine is negative square root 2 over 2. And sine's y. Yeah. So again, it would be good, I think y'all still have your unit circle. Yeah, because I'd be bringing that because it's going to be easy to look at this and find it than to try to have to go through the calculations. Because if we did this in the calculator, second sine inverse of negative square root 2 over 2 says here, negative pi over 4. Well, we need to get it positive, so we have to add 2 pi to it. So it gives us the 7 pi over 4. Now, because that's not the only angle that is true for that on the interval of 0 to 360, you get our two main ones, we'd have to go about finding sine's other angle, which is our 5 pi over 4. But the unit circle gives it to us no matter which one it is. So that is the nice thing about the unit circle. Questions on this here? We can look at another one. Cosine of x minus square root of 2 equals negative cosine of x. Again, since we just have cosine, and instead of the first power, we can get all the cosines together and get everything else on the other side. So the first thing I can do is add cosine of x to both sides, because negative cosine of x plus cosine of x is 0, giving me 2 cosine of x minus the square root of 2 is equal to 0. So the next thing we could do is add square root of 2 to both sides. Minus 2 cosine of x is equal to the square root of 2. And the last thing we'll need to do is 2. Divide both sides by 2. Minus cosine of x is equal to the square root of 2 over 2. Now we need to find what angles tell us or give us a cosine value of square root 2 over 2. On the unit circle, we're looking at the x values, the first value of the ordered pair. One of them is going to be pi over 4, and the other is 7 pi over 4. In context, this is the first quadrant, and this is the fourth quadrant. We're in the first and fourth quadrant. Questions on how we got to this point? Did it restrict the values of our angles, what our angle can be? No, it just told us to solve, right? So we can have any angle. It's not stuck between 0 and 360, 0 and 2 pi. And whenever we have that, we have to add the function's period to it. And the period for cosine is 2 pi. So we add 2 pi n. N gives us all the iterations from it, positive or negative. So if we said n was 0, we just get pi over 4 or 7 pi over 4. If n is plus 1, we're adding, or positive 1, we're adding 2 pi. If n is negative 1, we're subtracting 2 pi. We get every coterminal angle from it. So those are it there. Questions on this here? Questions on anything we've done so far? Here we have 3 tangents squared of x minus 1 is equal to 0. Now, this here we could treat the same as 3x squared minus 1, because again, we only have a single trigonometric function. For 3x squared minus 1, this is we can treat this or solve this by the square root method. We can solve 3 tangent squared of x minus 1 is the square root method, because again, the square root method works as long as we don't have a middle term. Here, our middle term would just be tangent of x. So if we have this, we need to get tangent by itself, tangent squared by itself. So what can we do first? Add 1. Because our negative 1 plus 1 will cancel out, telling us that we have 3 tangent squared of x is equal to 1. Then we would divide by 3. Three tangent squared divided by 3 is going to be tangent squared of x is equal to 1/3. And last but not least, we would square root both sides. The square root and square will cancel, giving us tangent of x is equal to plus or minus, because whenever we take the square root of both sides, we have to add the plus or minus. Now we still need to simplify our square root of 1/3. Now, unfortunately, the graphing, or either calculator, the 30xs, if we just type the square root of 1/3 in, it'll give us a decimal and won't convert it back into simplest radical form. However, if we rewrite it as the square root of 1 over the square root of 3, for whatever reason, it'll leave it in radical form. It is the exact same thing, but for some reason the 30xs needs it written that way. So when we take the square root of 1/3 and leave it in radical form, we have the square root of 3 over 3. Positive, negative, square root of 3 over 3. Write that a little bit nicer. Questions on this here? Is tangent listed on the unit circle? So if we looked at the unit circle, could we find the value of tangent? No. But yes, it's one of those yes and no. Because no, it's not listed. But what is tangent? Sine over cosine. Also, if you look on the back of your sheet, mine looks different than yours. We do have that little table, yes? So from 0 to 90, 0 to pi over 2, tangent is square root 3 over 3 at what value of x? Or what angle? 30 or? So that is one of our angles. And it works out that any pi over 6, because pi over 6 it is positive square root 3 over 3, which is one of our angles. Now at all the other pi's over, or not pi over 3, pi over 6, we're going to have our other ones. Because this is, I'll say that these are positive. Now it's going to be negative square root 3 over 3 at 5 pi over 6. Because interestingly enough, the square root 3 over 3 for tangent shows up at all of our iterations of pi over 6. Because we have pi over 6 in the first. Now 5 pi over 6 is our other one. And I'm just going to draw this in so we can see it. You don't have to write this out. Because the point is negative square root of 3 over 2, comma 1/2. Sine's 1/2. Cosine's negative square root of 3 over 2. And if we do calculate this out, we do get negative square root of 3 over 3. Turns out our other positive is at 7 pi over 6. Because 7 pi over 6 is down here, and our angle is negative square root of 3 over 2, comma negative 1/2. And I need to move that there. I'm going to list all 4 of them. So the first one in the first quadrant is our pi over 6. 5 pi over 6. 7 pi over 6. And this here is 11 pi over 6. Questions on this here? This might seem a little odd. Now, the range, or the period, for tangent is not 2 pi. The period for tangent is pi. That's why we have 4 iterations between 0 and 2 pi, because it repeats every pi. So from 0 to 2 pi, tangent, each value repeats itself twice. Questions on this here? So, since it didn't specify, we're going to add pi in. To all these terms here, because the period for tangent and cotangent is pi. Questions on this here? So, now, part of the reason I know this is just based off of our unit circles, and if you've noticed with the unit circle, with sine and cosine, the values repeat themselves, depending on the sign or the quadrant. Because in the first quadrant, sine is either 0, 1/2, square root 2 over 2, square root 3 over 2, or 1. And if we keep going around, it's square root 3 over 2, square root 2 over 2, 1/2, 0. It just repeats itself all the way around. Now from 0 to 2 pi, the only value that sine does not have more than once is 1, or -1, because the sign changes for that there. There are questions on this so far? We good with this so far? Now there is something interesting with this here. As we said, our one here, pi over 6 is our first angle that we have, yes? So we have every coterminal angle. Now if I take pi over 6 and add pi to it, what do I get? 7 pi over 6. Wait a minute. Isn't that this one here? So really, these two statements can be condensed to just x is equal to pi over 6 plus pi in. Those are the same statement. The same thing is true with our negative case. Instead of having both, we can just have this as 5 pi over 6 plus pi in. Because the distance from here to here is pi. The distance from here to here is also pi. So we don't have to list it twice to get all of our angles. Questions on this here? We're ready to look at the next one. Four sine squared minus 3 equals 0. Again, just like with the last one, we can get sine by itself and find our values. Now the first thing we can do here is add 3, which will tell us that 4 sine squared is equal to 3. At this point here, we can divide both sides by 4. And when we divide both sides by 4, we get that sine squared of x is equal to 3/4. And lastly, we would square root both sides. Now the square root of sine squared is just going to be sine of x is equal to plus or minus. Now we need to take square root of 3/4. And if we plug this in, we simplify this down, we get the square root of 3 halves, because the square root of 3 doesn't simplify, but the square root of 4 is 2. So we get the square root of 3 halves. Now the nice thing with this one here is that it is on the unit circle. So we're looking for the y values where sine of x is equal to positive or negative square root 3 over 2. Where's the first place where we see that sine is either positive or negative square root 3 over 2? Pi over 3. Where's the next one? 2 pi over 3. What after that is? 4 pi over 3. And the last one is? 5 pi over 3. Questions on this here? Now, did it specify what kind of angles we could have, or where our angle is located? Well, no, it didn't tell us that x had to be between 0 and pi over 2 or 0 and 360, so we also have all of the coterminal angles. So we add the period of sine, which is 2 pi n, to each one of these here to get all of our angles. Questions on this here? Now, this one here is a little interesting, and it's mainly to do with the fact that we have the positive and negative case for sine and cosine, or negative case for sine, not cosine. Because on the unit circle, our first angle is pi over 3. Our second angle over here is 2 pi over 3. Our angle down here in the third quadrant was our 4 pi over 3. And our last angle down here was 5 pi over 3. We're good with saying that there, yes? What is the distance? What is our angle value between pi over 3 and 4 pi over 3? What would I need to add to pi over 3 to get the 4 pi over 3? 180, or what's 180 degrees in radians? It's pi, yes? Well, how about 2 pi over 3 to 5 pi over 3? It's a distance of pi, yes? And we do have this flip back and forth from one to the other, because adding 2 pi to pi over 3 will get me all the way back to pi over 3. But if I just add pi to it, I get 2 or 4 pi over 3, yes? Where would I go? Or what would be the coterminal angle? Not coterminal. So if I added pi to 4 pi over 3, where would I get back to? Pi over 3 is coterminal angle, yes? And really just adding pi to it, I would go back to 4 pi over 3, and they'd go back and forth, yes? And the reason I point that out is because, well, these two here really are just pi units away. They would jump from one to the other, yes? So we could actually condense this down to just saying that x is equal to pi over 3 plus not 2 pi n, but pi n, because they are pi units, or 180 degrees apart from each other, because just adding pi in would go from pi over 3 to 4 pi over 3. The pi over 3 is coterminal. 4 pi over 3 is coterminal, and they would just jump back and forth. Now the question is, why didn't we do it on the previous one, like this one here? Well, these two are in the first and fourth, yes? So if I wanted to go from pi over 4 to 7 pi over 4, well, from pi over 4 to 7 pi over 4, we'd have to add 3 pi over 2 to it to go from here to here. 3 pi over 2. Well, that's fine. We go from 7 pi over 4 to pi over 4 is coterminal angle. We'd have to add pi over 2. That's not the same value. It's not the same angle. I can't just jump from one to the other like we can with pi. So I can't merge these because they are different. But because these two here are separated by distance of pi, I can simplify that down. Same thing's true with these two here. So I can, or 2 pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n, I can simplify down to 2 pi over 3 plus pi n because those are separated by a distance of pi. Does that make sense? Now, if you don't see that or don't remember that and you give me all 4, that's perfectly fine. I'll take all 4 because that is still the correct answer. It's just that we can write it a little bit nicer. Questions on this here? I mean, there is always ways that we can check this. 4 sine squared minus 3. We do have this here. Now, again, our first one was pi over 3, I believe. Well, pi over 3 is not going to be a nice value, but if remember, we can go second trace value, pi divided by 3 is 0. Second trace value. So here it was 3 pi. No. 2 pi over 3. Pi divided by 3 is still 0. Second trace value. 4 pi divided by 3. 0. Trace value. 5 pi divided by 3 is 0. And we can check any and all of those to make sure we indeed get the correct answer. Questions on these here? All right, we're going to stop there. We'll pick this up tomorrow.